Simplifying fractions, also called reducing fractions. We'll first talk about what equivalent fractions are. Fractions that have the same value are called equivalent fractions. Here's an example of some equivalent fractions. 1/2, 2/4, 4/8, or 2/4, and 4/8. If you look at the diagrams at the bottom of the slide, you'll see that the first fraction is 1/2. We have the same rectangle drawn all three times, but it's partitioned in only two equal squares. So the first one is only 1/2 a shade. And the second fraction is it's partitioned into fourths. So there's 4 equal partitions. And 2 are shade. And the third one is there's 8 equal partitions, partitioned into 8 equal parts, and so only 4 are shaded. But notice that there's still the same amount that's shaded in all three fractions because they're equivalent fractions. Now a fraction is written in lowest terms when the fraction is expressed using the lowest numerator and denominator possible. So 1/2 would be the fraction in lowest terms because it has the lowest numerator and denominator of all three fractions. Okay, reducing fractions or simplifying. Reducing is a process of converting a fraction to an equivalent fraction in lowest terms. It is done by dividing both numerator and denominator by the largest factor that divides evenly into both numbers. The largest number, is also called the GCF, greatest common factor. Now, if we do not use the GCF, it's not critical, it just means that we're going to take more steps. It doesn't matter, we'll still get the same answer. It's nice to use the GCF, but if not, it'll still work out. So let's get started. Here's our first example, 12/18. So number 1, find the GCF. What's the largest common factor of 12 and 18? What's the largest number that divides evenly into both 12 and 18? Yeah, that's right, 6. 6 is the largest number that divides evenly into 12 and 18. So now what we're going to do is divide both numerator and denominator by the GCF. So divide both of them by 6. So 12 divided by 6 and 18 divided by 6. 2/3. 2/3. And that's the answer because there's not another number that divides evenly into 2 and 3. And that's because we used the GCF. Now you could do that division by 6 in your head. You don't have to write the divided by 6. You just divide each of them equally by 6 and end up with your answer of 2/3. Okay, let's do the same problem again. And this time, maybe we don't use a GCF. We just use the number that comes first to us. So divide by any common factor. Maybe you saw that 2 goes into both numbers because it's even. Both numbers are even. So if you first divide them both by 2, let's see, 12 divided by 2 is 6, and 18 divided by 2 is 9. Now we got to keep going. We're going to divide both numerator and denominator by any common factor again. Continue this step until the numerator and denominator do not have a common factor. So is there another number that goes into 6 and 9? Yeah, that's right, 3. So divide both of them by 3, and we still get the same result. Took 2 steps, not a big deal. Okay, let's do another problem. 30 over 75. Let's try to find the GCF. Let's see, what's the largest number that goes evenly into 30 and 75? Well, maybe we should just do the tree for both numbers. And that way we can see what it is. And I know some people are like, oh, I don't want to do that. But really, the tree is so useful in many topics doing the prime factorization. And when we get to fractions or bigger numbers, it's going to be really useful. Okay, so 30 is 5 times 6. 6 is 2 times 3. Okay, so 30 is 2 times 3 times 5. 75 is 3 times 5 times 5. Do you remember what we do? We circle what's common. What do they have in common? They have a 3 in common and a 5 in common. And you multiply the numbers from one row, and that gives us our GCF. So our GCF is 15. So now we're going to go ahead and divide by 15, because it's the largest number that divides evenly into both numerator and denominator. So 30 divided by 15, and if you look at the numbers that's not circled on 30, you'll see that the number left over is 2. And that makes sense. 30 divided by 15 is 2. And then look at the 15, I'm sorry, look at the 75. What's not circled? 5. So the numbers that are not circled, that's going to be what's left over. Or you could perform the division, 75 divided by 15. Just a little shortcut there. Okay, let's do another problem. That same problem, 30 over 75. Last time we used the GCF. This time let's not use the GCF. Let's just see what comes to our head first. Maybe it's 5. So divide both of them by 5 and you get 6/15. And then what goes into 6 and 15? That's right, 3. Still the same result. Okay, let's do the next problem. 6 over 24. Let's see, what can we divide? What's the largest number that goes into them? 6. Maybe you see that, maybe you don't. Maybe you just say, well, let me just start with 2 because they're both even. So 1/4. Or maybe you go ahead and try dividing them both by 6. You still get the same result with only one step. Okay, so finding the GCF, the prime factorization, when the numbers are pretty small, you really don't need to do that. But as they get larger, it does get to be quite necessary. Let's see, 51 over 85. What number divides evenly into 51 and 85? Is it 2? No. 3? Let's see, 3 goes into 51, but 3 doesn't go into 85. 8 plus 5 is 13. No. Yeah, many people just leave this because they can't find a number that goes into evenly. But not you. What you're going to do is find the GCF by doing the prime factorization of each number. So let's see, 51, 5 plus 1 is 6, so 3 goes into it. So that means that 51 is 3 times some number, so divide 3 into 51, and you'll get 17. And 17 is prime. 85, let's see, not 2, not 3. Oh, 5, because it ends in a 5. So divide 5 into 85 so you can see how many times it goes into it. Oh, that's it. Now can you see what number goes into 51 and 85 evenly? I don't know why that's a 28 there. That's right, it's 17. The GCF is 17. So now we could divide both numerator and denominator by the GCF, which is 17. See, if we didn't do the prime factorization, would we have found that 17 was a number that goes into evenly? I mean, how many of us know our 17 times tables? How many would have said, oh, it's 17? Do the tree. Do the prime factorization. And then you'll be able to see what number goes in evenly. So divide both by 17 and notice that the results, let's see, for 51 divided by 17, what's left in that row? It's a 3. And 85 divided by 17, what's left in that row? It's just a 5. So the answer is 3/5. So doing this prime factorization is extremely important, especially when the numbers are large. You could stay with the other method if the numbers are small, but then on problems where you have large numbers, you're just going to have blank answers, and that's not good. So that gives us a second method for reducing. It's called the prime factorization method. It's more efficient when the fraction contains large numbers. This method requires writing the prime factorization of both numerator and denominator. Since any number divided by itself equals 1, we will line out any like factors that are contained in both numerator and denominator. Okay, so step 1. I know sometimes when you see notes it gets to be overwhelming, and then when you see an example, it's, oh, okay, now I get it. So try to write down the notes if you don't already have it in your textbook. Okay, step 1. Find the prime factorization of the numerator and denominator. Rewrite the fraction using the prime factorizations. Then step 3, line out one for one like factors that are contained in both numerator and denominator. And step 4, if more than one number remains in the numerator or denominator, multiply the remaining factors to obtain the reduced fraction. So if there's only one number, then that's the answer to that numerator. If there's two numbers, you multiply to get that result. Okay, so you might want to take a minute and write down the notes. Hit pause, otherwise we're going to keep going. Here we go. 39 over 130. So step 1, do the tree. Find the prime factorization for both numerator and denominator. So 39 would be 3 times 13, and then 130. So go ahead and do that on your scratch work, and then I'm going to put it up right underneath this. You're going to have 13 times 10. 10 is 2 times 5, so you should get 2 times 5 times 13. Okay, so that's the prime factorization for each number. Now you're going to rewrite the fraction using the prime factorizations. So for the 39 on top, you're going to replace it with 3 and 13. With the 130 on the bottom, you're going to replace it with 2 times 5 times 13. And now you can line out like factors. It's a one-for-one canceling. So if you see the same number on top with the same number on the bottom, you can cancel them out. So what cancels? The 13s, right. So those two 13s cancel. Does anything else cancel? No. So what's left in the numerator? Just a 3. What's left in the denominator? 2 times 5, and then multiply that, so that should give you 10. So our answer is 3/10. I know it took a couple steps, but take your time, and it could be done. Just do the tree, write down the numbers, cancel, multiply what's left, and it's done. 70 over 98. You might want to pause the video, work it out on your own. then click back on play when you're ready. So find the prime factorization for both numerator and denominator. 70 is 2 times 5 times 7, because 70 was 10 times 7, and 10 is 2 times 5. 98, let's see, it's 2 times 49, and 49 is 7 times 7. Okay, now rewrite the fraction using the prime factorizations. Okay, so what cancels this time? Right, a 2 on top with a 2 on the bottom. It's got to be one number on top with one number on the bottom. It can't be two numbers on top or two numbers on the bottom. It's got to be one number on top with one number on the bottom. Same number. Let's see, does anything else cancel? Right, a 7 on top with a 7 on the bottom. So there's only one remaining factor in the numerator and denominator, so that's our answer, 5/7. Is it feeling better? Yeah, it's not too bad. Just take the time and do the prime factorization. There's no thinking about, oh, what goes into this number and what goes into that number. Just do the tree, do the prime factorization, put the numbers in, and line out like factors. Okay, one more problem. Oh, this is a good one. 231 over 315. Okay, let's get started. Again, you might want to pause, find the prime factorization of each number. Don't forget to use your divisibility rules. Okay, 231. So you might try that 231. Let's see, 2 doesn't go into it, but 3 does. Because 2 plus 3 plus 1 is 6. So start with 3, and then you get 3 times 77, and then 77 is 7 times 11. And then 315, let's see, you can either start with 3 or 5. So for 315, you should end up with 3 times 3 times 5 times 7. And now rewrite those in the fraction form. Okay, and then what cancels? Let's see, a 3 on top with a 3 on the bottom. And a 7 on top with a 7 on the bottom. And let's see, multiply what's left. Well, there's only an 11 on top. And then 3 times 5 on the bottom, so our answer is 11/15. Okay, that's the end of this lesson. I'll see you here for the next one. Have a good day. Bye.